Okay, lesson 19 again, dividing complex numbers. We've already done adding and subtracting complex numbers, multiplying, now we're doing dividing. And dividing is, we're not really doing too much dividing here. We're going to be doing this thing called rationalize the denominator. Okay, making the fraction look like an appropriate form of what it should look like, okay? And we call it dividing because it's fractions. The middle line of the fraction bar is dividing. So dividing complex numbers is what we're doing. So here are the steps. If you are on the video, please pause now. All right, here we go. Numbers 1 and 2, watch what I'm doing. Okay, let's look at numbers 1 and 2. It looks a little scary right now, okay? I just need you to watch right now. I'm going to explain one thing before we move on. Okay, I'm going to teach you one thing. This thing is called a conjugate, okay? So this word's called a conjugate. So on my first denominator, I have an imaginary number. We don't like imaginary numbers in our denominators in math. Okay, we don't like them. Okay, just like we don't like fractional exponents in math in our denominators. We don't like imaginary numbers in our denominators. So this is an imaginary number, a complex number, and this is a complex number with an imaginary number in it. On number one, this is our imaginary number, and it's a complex number, but I can make it a true complex number by putting a 0 there, right? Would you all agree that this is what it means? 2i means 0 minus 2i. Did I change anything by putting a 0 there? No. Y'all follow me so far? So the conjugate's very simple. The conjugate is just you keep the real part the same, and you keep the real part, which is 0, and you multiply by the opposite imaginary part, which is positive 2i. Okay, that's what it is. Okay, that's what a conjugate is. So on number 2, look up here on number 2, the conjugate would be the same. Same real part, which is negative 8, and then we do the opposite, which is negative 5i. Okay? Does that make sense? Everyone know what a conjugate is now? Okay, we do this so we get rid of the imaginary number in our denominator. Okay, so that's the background knowledge. So today I'm going to teach you how to deal with this. Okay, so I'm going to erase that so you can start working. So number 1, we have negative 7 over negative 2i. We have an imaginary number in our denominator, so we have to do this thing called rationalize the denominator. Okay, rationalize the denominator. Okay, so we take number 1, we got negative 7 over negative 2i. We know that the real part is a 0, so we don't really have to worry about it, but on our denominator here, we multiply by its conjugate, which is positive 2i, in the denominator. Same thing, whatever I do in my denominator, I also do in my numerator. Multiply by positive 2i, okay? We just multiplied by the conjugate. Now I'm going to multiply. Negative 7 times 2i is going to be negative 14i. Denominator, negative 2 times positive 2 is negative 4. I times I is I squared. Okay, you following me so far? What's I squared equal to, everyone? Okay, what's negative 1 times negative 4? Positive 4. Numerator still negative 14i. What goes into both 4 and 14? 2. So it's going to be 7i over 2. And then that negative sign in the numerator, I'm going to move it from the top just because I like it on the side. Okay, that's number 1. Okay, again, what did I do? I just multiplied the denominator by the conjugate because I needed to rationalize the denominator by multiplying by the conjugate on both the denominator and numerator. Multiplied, simplified as I went, and I got my final answer. That's number 1. Okay, watch me do number 2 now. Number 2, we got 9 over negative 8 plus 5i. Everything in the denominator is in its own parentheses. It's just grouped there. We just assume that they're grouped. Okay. So denominator has an imaginary number, so it's complex. I have to rationalize it. Okay. Did I say something funny? Oh, okay. So we got negative 8. That's okay if I do. Negative 8 minus 5i. That's our conjugate. Negative 8 minus 5i. In our numerator. Then I multiply. What's 9 times negative 8? negative 72. Numerator, 9 times negative 5i is negative 45i. Denominator. Okay, denominator is now nice because this is a difference of squares problem. This number and this number are the same. This number and this number are the same. I'm going to have to multiply it, and then we have a positive and negative. So this is a difference of squares problem. So I'm just going to multiply. Negative 8 times negative 8 is positive 64. 5i times 5i is 25i squared. And then you just put a negative sign in the middle. That's it, because it's difference of squares. That's the trick I taught you a couple weeks ago. It's the shortcut. Okay, numerator stays the same. There's nothing I could do with the numerator. Negative 72 minus 45i. Denominator, I squared over here becomes negative 1. Negative 1 times negative 25 is positive 25. Then we got 64. Denominator, I could still simplify. 64 plus 25 is 89. And then we got negative 72 minus 45. Now, in my numerator, I know 3 goes into both of these, right? Does 3 go into 89? No. 89, there's nothing that really goes into 89 in all of these numbers. If there was, I would factor it out and cancel it out. Okay, but since we can't, that's it. We just box our answer. We're all done. So number 2 is the harder version of what you're going to do today. Number 1 was the easier one. Okay? So this whole thing's called rationalize the denominator, multiplying by the conjugate, and then you simplify as you go. It's a little harder, but you could do it. Okay? Questions? All right. 2 set of ones about number 1, specifically why do we rationalize and why do we multiply by the conjugate, and then 1 set of 2s about number 2. The whole problem. Ready? You're talking right now. I'm going to give you a solid minute to talk, and then you can write. No writing right now. Ready? Go. Okay, number 3. Turn to your neighbor. Tell him what do you think the conjugate is on number 3. What? Negative 8i. Good. So we're multiplying the denominator times negative 8i. Same thing we do to the numerator. Okay. I'll let you work that out. I'll give you about 30 seconds. Okay, looking up here, 3 times negative 8i is negative 24i. 8 times negative 8 is negative 64. I times I is I squared. I squared becomes negative 1. So what's negative 1 times negative 64? Positive 64, good. Shh. I'm talking right now. Please end your conversations. Okay, negative 24i over 64. Okay, then what goes into 24 and 64? 8 does, so 8 goes into 3 times, this would be 3i over 8. And then you could put the negative sign at the numerator, but I prefer it on the outside like so. That's it, okay? That's for number, so we do number 4 now. Ready? Go. Okay, on this one, of course, you're multiplying by the conjugate, which is positive 8i. So negative 1 times positive 8i is negative 8i. Denominator is negative 8i times positive 8i, which is negative 64i squared. So I squared becomes negative 64 is going to be positive 64 over with 8i, or negative 8i in the numerator. 8 goes in each of these, so you have I over 8, and the negative sign, again, just put on the outside like so. Okay? Make sure it looks like an I when you put your answer down, okay? You don't want it to look like this, where it's just a small little dot, because then, I might think that's 1/8, right? So we want to make sure it looks like negative 8i over 8. So if you made a mistake, please correct yourself. Here we go. Let's do number 5. Ready, set, go. Then I'll help start you off on this one. Remember, the whole denominator is its own parenthesis, so it's going to be, the conjugate should be negative 7 plus 3i, right? Negative 7 plus 3i. Okay, numerator is going to be negative 63 plus 27i squared. Denominator is going to be negative 7 times negative 7 is 49. Or 3i times 3i is 9i squared. And you just bring the negative sign down, okay? Keep going. Here we go. First thing I do, I'm just going to work in little chunks. So in the numerator, I know I could deal with this I squared. This I squared becomes negative, so positive 27 times negative 1 is going to be negative 27. Denominator still going to have negative 63i. And in the back of my head, I know that's a multiple of 9. The denominator has I squared also, so negative 9 times negative 1 is going to be positive 9. And then we have 49 here, so we got 49 plus 9. Okay, 49 plus 9 we know is 58. So 58, and then we got negative 63i minus 27. We know 58 is a multiple of 2. It's not really a multiple of 4. It's not a multiple of 6. Yeah, so it doesn't really go into 9 or 3, okay? So we can't really simplify that. So since the numerator has an imaginary number, we should make it complex, right? So it should have negative 27 minus 63i all over positive 58. So this should be their final answer, right? Because I want it to look pretty. Okay, that's it. That's your answer. Okay, I'm going to stop there.